My initial idea was to use a glove-like device for a phone that could be signed through. The glove would track your finger position and your hand movement. It would then input that information into a computing device, such as a computer or a smartphone. That information could then be translated into a digital representation, which would be sent to another phone and played on the screen. This would allow deaf people to use phones almost in the same way hearing people use phones. The difference would be that they would still have to look down at their phone screen. This was a problem because having to look at your screen is the very thing that makes texting inconvenient. However, I realized that I was thinking too narrowly, and that I could design a device that would be much simpler and much more versatile. The first thing I realized was that it did not have to be a glove. It would be much more convenient to wear a ring instead. Placing a 3-axis accelerometer in the ring and two simple touch sensors on either side of the ring, you could create a device that would be fully adequate for communication, in the same way as the glove just described. I also realized that rather than using a screen as the information portal on the receiver, it would be quite easy to create a device that would act like an etch and sketch, except that it would rest against the palm of the hand and would be felt by the wearer rather than seen. Following my philological sign language, it would have 3 pins that would move in and out at different points on the hand to signal the different positions. There would also be a pin in the middle to indicate the different hand movements. The device would be strapped into your palm, and the 3 pressure points would be here, here, and here. The movement pin would be here, and would make the same movements as my philological sign language. I have run a number of tests on the ability of the human body to decipher movements on the palm without the use of visual perception, by having a blindfolded subject tell me what type of movement/pressure combination I was creating at random on their hand. I recorded the results from different methods and calculated the percentage that was correct and the percentage that was incorrect. I determined that the nerves in the palm of the hand are indeed able to decipher the movements felt without the use of sight. The accuracy of the best method was extremely high, with mistakes ranging at only 3% in an untrained beginner, which is absolutely low enough to use in efficient communication. However, there are certain conditions that will improve the perceptive ability. One such condition that I discovered is the need for the pin to start its movement in a sensitive place on the palm and end at a similarly sensitive point. I found that the creases of the hand are more sensitive than the rest of the palm, and thus are excellent for this purpose. The upward diagonal movement in the direction of the thumb was particularly difficult for the test subjects to determine, and on the first 3 attempts was mistaken for a straight over movement. After I realized that it was easier to feel the movement if it ended in one of the hand's creases, however, the test subject had no difficulty in determining what movement was being made. Once fully developed, I believe that these technologies will be able to bridge the communication barrier between the deaf and the hearing. It would be quite simple to have the computing device output sound from the input of the signing ring, thus allowing the deaf to talk to the hearing. It would also be quite easy to have input from sound be output to the Etch-a-Sketch device. Between these, as technologies and voice recognition software improve, the deaf and the hearing could communicate with ever-increasing efficiency until eventually it will be hard to imagine that a communication barrier ever existed.